Have you ever wondered how researchers can look at this huge, messy mountain of chaotic data and somehow pull out a single, crystal clear insight? Well, today, we are prying open the lid on the toolbox they use to do exactly that.
I mean, it's the fundamental challenge, right? We're all basically swimming in an ocean of information. But how in the world do you find the real signal in all of that noise? Whether you're a scientist, you're in business, or you're just trying to make sense of things, this is the question we're going to dig into.
And that's where this idea of a toolbox comes in. I mean, think about it. You wouldn't use a hammer to try and saw a piece of wood, would you? The same exact principle applies to research. You've got to have the right tool for the right job, and today, we're going to check out some of the most powerful ones out there.
Okay, first up, the tools that are designed to create order out of chaos. These techniques are all about grouping similar things together, simplifying what looks overwhelmingly complex, and revealing the hidden structure that's lurking inside our data.
So, our first tool is something called cluster analysis, and you can basically think of it as a digital sorting hat for your data. Seriously, you feed it a big, messy data set, and its algorithms automatically find the natural groups, sorting everything based on what they have in common. And this sorting process works in two main ways. The hierarchical method is pretty strict. Once a piece of data is put into a group, it's locked in for good. But the partitioning method, on the other hand, is way more flexible. It actually lets data points move around during the analysis to find the absolute best fit.
Next up, we've got factor analysis. Okay, imagine you have a super complex recipe with like 50 ingredients. Factor analysis is the technique that figures out that those 50 ingredients really just create a few core flavor profiles, like savory, sweet, and spicy. It boils down a huge list of variables into just a few meaningful underlying factors. And this process helps us uncover something called a latent construct. It's a really powerful idea. It's a concept you can't see or measure directly, like brand loyalty or employee morale, right? You can't put a ruler next to those things, but you can see their effects in the things you can measure, like how often someone buys a product or what they say in a survey. And this is just a brilliant way to illustrate that idea. Flavor itself is a latent construct. You can't see the idea of savory all by itself, but you totally understand it by measuring its ingredients, the salt, the herbs, the spices. Those ingredients are the observable variables that all point to that unobservable factor.
So we've grouped our data, we've simplified it, now what? Well, let's grab some tools that help us understand how all the different pieces of our data actually relate to each other. We're moving from what the patterns are to why they might be happening.
This brings us to path analysis. Think of this one like a GPS for your data. It lets you draw a map of how you think different variables influence each other. And then, path analysis actually tests those routes, telling you which connections are like superhighways and which are just quiet little country roads. And if path analysis is the GPS, then structural equations modeling, or SEM for short, is like the whole Google Earth suite. It is a much, much more powerful version that lets you test an entire complex theory, a whole map of interconnected ideas, against your real-world data just to see how well it holds up. But, and this is a huge but, here is the crucial warning label for this tool. SEM can tell you if your theory about what causes what is plausible, but it can never definitively prove it. It shows you really strong correlations and how well your model fits the data, but it's not a guaranteed cause and effect relationship. So think of it as a powerful guide, not a final verdict. Okay, so far our tools have been all about understanding the data we already have. But what about using data to make better choices for the future? For that, we've got a really specialized tool. It's called the Analytic Hierarchy Process, or AHP, and it's designed to bring logic and structure to really complex decisions.
So AHP breaks a really tough choice down into 5 pretty manageable steps. First, you build a hierarchy of your main goal, your criteria for success, and all your possible alternatives. Then, you rank how important each of those criteria is to you. You weigh your alternatives against each one, you check your own logic for consistency, and finally, the process calculates a score, revealing the best possible option. It's such a powerful way to bring clarity to a tough choice.
So, we've got these amazing tools that can find patterns, map relationships, and guide decisions. But here's the thing. Having a powerful toolbox is only half the story. The other half, and you could argue it's the more important half, is knowing how to use those tools correctly and responsibly.
And this brings us to the researcher's ethical compass. You see, if all these techniques are the tools, then ethics are the safety manual and the guiding principles for using them. Without this compass, even the most sophisticated analysis can be misleading or even downright harmful.
At the very core of this ethical compass are three foundational ideas, famously outlined in what's known as the Belmont Report. First is respect for persons, which means treating individuals as autonomous agents. Second is beneficence, the duty to do no harm and to maximize any possible benefits. And third is justice, making sure that the burdens and the benefits of research are shared fairly.
So what do those big principles actually look like in the real world? Well, it means getting informed consent from people. It means being totally honest about risks and making sure everything's fair. It means you represent other research accurately. And it means acknowledging the limits of your own tools, just like we saw with SEM, and being honest about what your analysis can and cannot prove.
And in our digital age, respecting people and protecting them from harm, well, that extends directly to the data they share with us. Protecting personal data isn't just some technical issue. It's a fundamental ethical obligation. And the rules for handling that data are crystal clear. You have to have a specific, lawful reason to collect it. You can only take what you absolutely need, nothing more. You're responsible for keeping it secure, and you can't just hang on to it forever. You know, these aren't just good ideas. They're non-negotiable principles for any responsible researcher.
Okay, so let's bring it all home. We've looked inside the researcher's toolbox at all these powerful techniques they use, but we've also spent time on the essential ethical compass you need to use them wisely.
And this right here is the single most important takeaway. Analytical skill and ethical integrity, they are not separate qualities. You simply can't have one without the other if you want to produce work that is not just clever, but also credible, responsible, and true. They are completely and totally intertwined.
So I'll leave you with this final thought. This knowledge really empowers you to be a more critical consumer of information. So the next time you see a study or some big statistic, don't just look at the headline. Ask how they found it. Ask about the tools they used and the principles that guided them. Because the most powerful insights aren't just discovered, they're built with integrity.